Hello everyone, welcome to the new series about the time series. Today we're going to look at the EDA or exploratory data analysis on the time series. First, let's load the package ASTSA. Then let's fit a linear model on the chicken dataset. So the predictor will be the time, and then we will plot the residues, and also we'll look at the first order of the differencing on the dataset. As we see, the residues is fairly randomly distributed. The first difference afterwards also show it's centering around 0, so looks like the linear regression on the time shows it has a trend with time. Here we're going to look at the auto cross correlation functions. As we can see, the ACF has a long tail to go. After the detrended or the residues, it decreased fairly quickly. So the first difference also very effective. However, it has some hidden patterns around the timeline, and maybe it shows a some kind of a seasonal or cyclic effect, as we can see here. Another example, we'll do some of the transformations to smooth down the variations or the fluctuations on the time series. After the log transformation, as we can see, and it has a more stabilized trend or variations. Also, the scatter plot matrix or some correlation plots will show whether the lags between the lags it has some relationship or not, or strong ones or weak ones or not at all, such as ones with this, the t minus 8, it shows the flat. The other has a fairly strong correlations like 0.6. And quickly skip this. This also shows some of the smoothing effect. As we can see, it has some negative correlations between them. So this is for the exploratory data analysis phase. So it can give you some hints on how to select the modeling in the next phase. So it gives you some of the clues on how to construct a linear model further. Let's run this. To quickly show on this case, it has a linear regression effect. You know, and some of the interactions between them. Although the R square is not perfect here, but it shows some of the significant correlations between them. Then we can run a smoothing effect. Literally, it break it into two sections, larger than 0 and smaller than 0, using a dummy factor defined here. Well, let's take another look at the residues and its correlations. Here, I'll give you another examples to use the regression and to analyze the signals or the time series with noise, so you can extract the true trend out of the noisy data. As we can see here, the red line, it shows some of the overall trend, and it's very similar to a smoothing effect. Alright, hopefully this is not doing too rush on the explanation. You can go over these examples according to the textbook and the notes, and hopefully you can use it in your study or research. Bye bye for now.